Okay, welcome students to chapter 4. Let's jump in. Okay, chapter 4 notes are on graphs of circular functions. Okay, sine, cosine, basically the 6 trig functions: sine, cosine, tangent, cotangent, cosecant, and secant. We're going to start off with sine and cosine. The sine function, okay, it starts at 0, 0, goes up to 1 pi over 2, 1, down to, I'll put some points, reference points here, so you can see what I'm looking at. Maybe I'll put them in black. So it starts at 0, 0. It goes to pi over 2 and then up to 1, and then down to pi, or still down to 0 at pi, and then at 3 pi over 2, it's at -1, and then we're back to 2 pi. And this comes to us from the unit circle. We're looking at the y values as we go around the circle, okay? And every 2 pi, it's going to repeat, okay? So again, the sine function are the y values, okay? Those are the y values. And so the y value starts at 0, okay? Because it's at 1, 0 on the unit circle, and then it goes to 0, or then it goes to 1, sorry, at pi over 2, and then the y value is again 0 at pi, and then the y value is at -1 at 3 pi over 2, and then at 2 pi it goes back to 0. Okay, it just keeps recycling over and over and over again. Okay, and if we were to go negative direction, it would cycle in the negative direction as well. Okay, now each of these cycles is called one period. Okay, and for the sine function, the basic, we call it the parent function. The basic sine function, it has a period of 2 pi. It means it cycles, it cycles its values over and over again every 2 pi. Okay, and we get a mirror image every 2 pi units. Okay, now the height of the sine function is called its amplitude. Okay, so this is called its amplitude. It's actually 1/2 the total height. The amplitude. And the line that cuts the figure in half is called the midline. Okay, it cuts the function in half. That's called the midline. For the regular sine function, the midline is 0, y equals 0. The midline is always y equals some value. In this case, it's 0, which is the x-axis. Okay, the range is from -1 to 1. And again, 1/2 the range is the amplitude. So in this case, the amplitude would be 1. Okay, and we could stretch these functions, and we'll see how they're stretched and compressed and flipped. Okay, and it's an odd function, symmetric about the origin, which means that if I were to rotate this thing 180 degrees, I would get a mirror image. Okay. Okay, for the cosine function, it really is just the sine function, but it just happens to be moved -pi/2 units. It's shifted -pi/2 units. And again, this comes to us from the x value on the unit circle. The x value on the unit circle, it is going to start at 1, and then it's going to go to 0, and then it's going to go to -1, and then it's going to go to 0, and then it's going to go back to 1. Okay, so at 0 degrees, we start at 1 instead of 0, okay, because we're looking at the x values now on the unit circle as we cycle, as we go around and around this thing, okay. We cycle through these values. Let me highlight the values that we're cycling through. 1, 0, -1, 0. Okay, before when we cycled, we were, for the sine function, we were looking at the y values, and we would cycle through those values, okay? And so at 0, we're at 0. At pi over 2, we're at 1 for the sine function, okay, for the sine function. Okay, but for the cosine function, it's shifted, okay? We start at 1, and then we go to 0, and then we end up at -1. Now the amplitude on this is the same. It's still 1 because the midline is still at y equals 0. And 1/2 the total height of this is 1. The period is also, so the amplitude is 1. The period is still 2 pi because I get it to cycle through all the values in 2 pi just one time around the unit circle will give me a cycle. It's just, it looks a little bit different because of where we're starting and where we're ending, okay? And this is an even function, which means it's symmetric about the y-axis, which means that if I were to flip this across the y-axis, I would get a mirror image, okay? Okay, the period, the graphs of y equals sine b x and y equals cosine bx have a period of 2 pi over b. So if I have a value in front of the x, I just divide that value 2 pi over that value, and that gives me the period. The graphs of y equals a sine x and a cosine x have an amplitude of absolute value a. Okay, so this stretches things. This a value will stretch the height of my graph. Note, sine and cosine are both periodic functions, means that they continue to give the same values over and over and over and over again. The amplitude of the periodic function is equal to 1/2 the maximum value minus the minimum value. Okay. Oops. Okay, graphing sine and cosine functions. 1, find the period, label endpoints, the endpoints 0 and 2 pi over b. Okay, so we're going to find the period. Okay, starting at 0. Divide the interval into 4 equal intervals. Okay, divide this period into 4 equal intervals. Period over 4. Okay, evaluate the function at the 5 labeled values. So it's going to be 0 and the 4 intervals. Okay, and then plot the points from step 3 and draw the curve. If needed, we may draw the graph over additional intervals. Okay. Okay, so let's try to graph the cosine value here. First one here, it says graph y equals cosine 1/2 x over 1 period. Okay, so what's happening here? Well, the amplitude, well, let's look at what a is. A is equal to 1. Since there's no value in front of the cosine, we just assume it's 1. So we say a is equal to 1. So the amplitude is equal to 1. Now to find the period, okay, b is equal to 1/2. Okay, so the period is going to be 2 pi over 1/2. And when I divide by a fraction, I multiply by the reciprocal. So this becomes 4 pi. Okay, that 1/2 is going to flip and become 2. And 2 pi times 2 is 4 pi. So what we're doing here is we're actually stretching this out. The period originally was 2 pi, but now we're stretching it to 4 pi. Okay. So now that we want to know, well, what are the intervals that we're going to use for our reference points? Okay, in our previous cosine function, we have 1, 2, 3, 4, 5 reference points. Okay, so we had at 0, we're at 1. At pi over 2, we're at 0. At pi, we're at -1. At 3 pi over 2, we're at 0. And then at 2 pi, we're at 1. We're back to 1 again. So we want to divide the period, which is 4 pi. We want to divide that by 4, and that's going to give me divisions or intervals of pi units. So pi divisions. Okay, so we instead of going up by pi over 2s, we're now going to go up by pi's. Okay, so that's the only change here from the original function. We're still going up and down 1. Okay, so this is going to be at 1, and this is going to be at -1. Okay, but instead of going by pi over 2s for our 4 divisions, we're going to go by pi's. So the first one is the first, I don't want to point there. The first reference value is going to be at 0, and then the next is pi, and then I just keep adding. This is pi, or 2 pi, 3 pi, and then 4 pi, and that will give me 1 period. Okay, so this is basically identical to the graph that we have before for the cosine, except for the fact that we are stretching out the period. Instead of it one cycle happening over 2 pi, one cycle is going to be stretched horizontally, and it's going to happen over 4 pi. Okay, so at 0, we're still at 1. Okay, at pi, we're now at 0. It's going to create the same shape as before, but the intervals are just going to be different. At, excuse me, at 2 pi, we're at -1. At 3 pi, we're at 0. And at 4 pi, we're at +1. And we have to create the same shape that we had before. Okay, maybe I'll put this in red. Okay, and it's kind of like a UV shape. The very top of the function is at the 1 there, and the very bottom of the function is at -1. Okay, and that's 1 cycle, okay, or 1 period. Okay, example 2, graph y equals -3. The negative here does something interesting. We didn't talk about that in the previous page, but the negative for a, if a is negative, then we reflect or flip in the x-axis. Okay, so we flip this thing upside down. Okay, we reflect in the x-axis, or it basically gets flipped upside down. So the 3 tells me that I'm going to stretch this and have an amplitude of 3. So a equal -3 tells me that I'm going to flip and that I'm going to stretch vertically. Okay, so this is going to be an amplitude of 3, which is a vertical stretch of 3. Okay, and the 2 here, the b equaling 2, that's going to tell me that my period is 2 pi over 2, which is just pi. Okay, so what are my divisions going to be? Well, my divisions will be pi, the period over 4, pi over 4. So now instead of the original going up by pi over 2s, we're going to be going up by pi over 4s. Okay, so basically this is a what we call horizontal compression. Okay, so what did the original sine function? You need to kind of memorize what the original sine and cosine functions look like. I'll put a little one up here, but the original sine function looks like this. Okay, that's not too good. Looks like this. Okay, and where did it start? It started 0, and then it went to pi over 2, and then it went to pi, and then it went to 3 pi over 2, and then it went to 0. It's kind of like an S shape. And then it went to 2 pi. Okay, so that's the original there. Okay, so what is our new function going to look like? Well, it's still going to start at 0, 0, because if I stretch 0, it just becomes 0. Okay, if I multiply something by 0, it's just 0. Still going to start at 0, 0. The amplitude is 3 instead of 1. So this is going to go all the way up to 3 and all the way down to 3. Okay. So I like those divisions. 1, 2, 3. Okay. And instead of going up on the x-axis by pi over 2s, we're going to go by pi over 4s. So this is pi over 4. And then what's 2 pi over 4? If I add another pi over 4, I get 2 pi over 4, but that's pi over 2. And then if I add another pi over 4 to 2 pi over 4, I get 3 pi over 4. That doesn't reduce. And then I get 4 pi over 4, which does reduce to pi. Okay. So now to get this kind of S shape, this serpentine shape, I would originally go up 3 for my amplitude at pi over 4. However, this negative right here tells me that instead of going up initially, I have to go down initially. Okay, so everything is in the upside down. Okay, like from Stranger Things. Okay, and so we're going to go down 3 at pi over 4. Now we're going to go back to 0 because 0 times -3 is just still 0. And then we're going to go up at 3 pi over 4. We're going to go up to 3. Again, this is 3 and -3. And then we're going to go back down to 0. So we get a nice curve. Oops. Doesn't look like that. Oops. Looks like this. Stop. There we go. Like this. And then I think my divisions were too spread out, maybe. Let's make this point go over. Oops. Go over a little more. Okay, so now we've got this guy here. That looks better. Okay, so that's one period of that. Okay, for this sine. Okay, example 3. Graph y equals 2 cosine pi over 2x over 1 period. Okay. Go back to red for this one. So the 2 is A is 2, so it's not negative, so I don't have to worry about that flipping stuff. But this does tell me that the amplitude or the vertical stretch is 2. Amplitude is 2. Okay. So, and then B is equal to pi over 2. That's kind of interesting. So what's the period? The period is 2 pi over 2, which equals 2 pi times 2 over pi. The pi's cancel and I get a period of 4. That's kind of cool. So what are the divisions? Well, the divisions are going to be 4 over 4, which is 1. So I just go up by, the divisions are just going to go up by 1s. Well, that's kind of cool. Okay, so when I graph this, when I go to graph this, I know that I'm going to be going up to 2 and down to 2 at some point. And the divisions are just going to be going 1 to 4. And the increments are 1, 2, 3, and 4. Okay, they go up by ones. Oh, nice. So this is 1, 2, -1, -2. Okay, so where do we start with the cosine? Well, we start at the top, then we go through the midline, which is 0. Then we go down to the bottom, go through the midline again, and then go to the top. And so we get this nice curve that looks like this as our cosine value, as our cosine function. Okay. Okay, example 4, determine an equation of the form y equals a cosine bx, where b is greater than 0 for the given graph. Okay, so we can see that the amplitude here, the height goes to 2.5, right? So it looks like a is 2.5. Okay, nice, nice, nice. Okay, what about the period? Well, the period is how far it goes in one cycle, right? So the period ends up being 2 pi over 3. Okay, so if the period is 2 pi over 3, and I know that the period is supposed to be 2 pi over b, then what is b in this case? Well, b is equal to 3. Oh, okay. So we know that the function should have been equal to y equals 2.5 cosine 3x. Boom, that's it. Okay, that's 4.1. I will see you in the next video.